Okay. Anyway, I'll just do it again for you. Just 1 minute. Otherwise, you will not understand it. Okay, so is the concept clear? When some number is a factor, so that means remainder is going to be 0 in that case. Okay.
Yes, ma'am.
Okay. Oh, I did the full question and okay, anyway. So here's the third question. Your polynomial is this 3x cube and plus 7x, right? Okay. And this is your gx, which you have to check whether it's a factor or not. Okay. So factor usually we see in the form of x minus a, clear? So we have to bring it in this form. So what you do is put your gx is equal to 0. So you will get the value of x. So that is your a. Is that clear?
Yes, ma'am.
Okay, so you do 7 plus 3x is equal to 0. So 3x is minus of 7 and x is minus of 7 divided by 3. So this is your a, right? I mean, this is what we call a. Clear?
Yes,
So
ma'am.
now we check the value of the polynomial at this number, minus 7 by 3. So 3 into minus of 7 by 3 whole cube plus 7 into minus of 7 by 3. Okay, now 3. So this is minus and it has odd power. So 1 minus is going to be outside, right? 3 into, so 7 cube is 343 that you can check. And then 3 cube. So I can write it as 3 into 9 so that I can just cancel it. Okay. 1, 3 I'm writing like this. Now again, plus minus, minus 7 into 7 is 49 divided by 3. Is this clear?
Yes, ma'am.
Okay. So now you are left with minus of 343 divided by 9 and minus of 49 divided by 3. So you can take LCM here. See, obviously it's not going to be 0, that you can see. For example, you
Yes.
have minus 2 and minus 2, it's going to be minus 4. It's not going to be 0 in any case when there are different numbers. Okay. If one is
Yes,
minus
ma'am.
2 and other is just the same number with opposite sign, then it's going to be 0. But so you can just simplify this, take LCM, which is 9. So minus of 343 and then minus, so 3 into 3 and then 3 into 49. So 49 into 3, 3 into 9 is 27, 12, 13, 14. So minus of 147. Now minus and minus, so both will add, but with a minus sign. So 7 and 3, 10. Carry 1, 4 and 4, 8 and 1, 9, 3 and 1, 4, and then divided by 9. So obviously it's not 0, right?
Yes, ma'am.
So that means it's not a factor. So you will say that P at minus of 7 by 3 is not equal to 0, and therefore your gx is not a factor of px. Is that clear?
Yes, ma'am.
So let us revise now exercise 2.4, right? Okay, you can write it. So exercise 2.4 is again, it is factorization of poly. I think it's not in the syllabus. Let me just check. Zeba has sent me some, sorry, Jesslyn has sent me her syllabus. Okay, it's complete, right, Jesslyn?
Yes, ma'am.
Polynomial chapter is complete. It will come in exam. Now, please open exercise 2.4, both of you. So, Jaslyn, any question which they have cut from this exercise? Is there any question?
Ma'am, I don't think so.
Okay. So, I hope both of you are also having your notes.
Yes.
Okay.
Ma'am, in polynomials, nothing is cut.
Yeah, okay. It will come full, and I mean, you require a lot of practice in this chapter. Okay.
Yes, ma'am.
Please don't take it that lightly. So anyway, Zeba, let's revise exercise 2.4 now. First question. So determine which of the following polynomial has x plus 1 a factor. So again, use your common sense. You have to check whether x plus 1 is a factor or not. So what you will see? Yeah, Zeba, how can I say that x plus 1 is a factor of this polynomial? Obviously, it should give my remainder 0, isn't it, Zeba? Zeba.
Yes, ma'am.
See, obviously, if I want to see that x plus 1 is a factor of this polynomial, so what will I see? I'll see whether my remainder is coming 0 or not. That's the only thing I'll check. Is that clear? Yeah.
Yes, ma'am.
So the step is check whether the remainder is 0 or not. Okay. So if your remainder is 0, so this is a factor, right? So x plus 1 is a factor. Is that clear?
Yes, ma'am.
And if your remainder is not 0, then I'll say that x plus 1 is not a factor. So this, I hope this is understood to both of you now. I mean, it's very common sense that if remainder is zeros, obviously it's a factor, right? Okay, now how to find remainder? That's the question. How to find remainder? This you also know from the remainder theorem that when x minus a is a factor, so that means the value of polynomial at a is your remainder. This is the way to find remainder. We just find the value of polynomial at this number and this is the remainder. Now, if this is 0, it's a factor. If it is not 0, it's not a factor. Is it clear?
Yes, ma'am.
Okay, so first question, first part. So gx is same in every question. So gx is x plus 1. So it's written x plus 1. So that means it is x minus of minus 1, isn't it? So this is your a. A is minus 1 here. Or you can find it like this also. If you do your gx is equal to 0, so that means x plus 1 is equal to 0. So this will give you x is equal to minus 1. So this is your a. Is that fine?
Yes, ma'am.
Okay. Now just find the value of polynomial at this a. So I want to find p at a. That means I will find p at minus 1. So put, this is your polynomial. The first part, x cube minus of, sorry, plus of x square plus of x plus of 1. Now put minus 1 everywhere. So minus 1 whole cube plus minus 1 whole square plus minus 1 plus 1. Hmm? So odd power, so minus 1, right? Plus. Now even power, it will become 1. Now plus minus, minus, and minus 1 and then plus 1. So This minus 1 plus 1 cancel out, this minus 1 plus 1 cancel out. Okay. Or you can write like this: minus 1 is minus 2, and plus 1 is 2, and again it is 0. So your P of A is 0. What does it imply? That, sorry, right, P at minus 1 is equal to 0. So that implies that Gx is a factor. Is it clear?
Yes, ma'am.
Or you can say that x plus 1 is a factor. This is your Gx. Now, please do second part, third part, fourth part very quickly. Please check whether the remainder is 0 or not, and then ask me where you have problem. Seba, is it understood now?
Yes, ma'am.
Okay. So you will simply check P at minus 1 in every part, okay? Because your Gx is same.
Yes, ma'am. Yes, Zeba, second part. Is it a factor or not? Now I'm just solving.
Hmm. Okay, how much is P at minus 1? Tell me, second part. Zeba, how much is it? P at minus 1? Second part? What is the value you are getting? Please unmute yourself, both of you. See, Zeba, second part is this x4 plus x cube, again plus x square plus x plus 1. Am I right? This is your Px. Clear? Please unmute yourself, both of you. Jesslyn.
Yeah.
Okay. Okay, Zeba is trying to join. What's your value, Jesslyn? Yes, Zeba. How much is P at -1? Second part. I'm not able to hear anybody. You can type, Jesslyn. I'm not able to hear you. -5. No, Jesslyn, it's not -5. Second part. See, now you have even power. Okay, it will be only 1 plus. Now you have odd power. So it will be -1. Again, you have even power. It will be 1. Then this plus minus minus and sorry, -1 and then +1. Okay. So now you can open the bracket. So 1 plus minus minus, then +1 -1 +1. So how many plus are there? 1, 2, 3. So this is 3 and then minus of 2. So I'm getting 1 here. Zeba, are you getting 1?
Sorry, no. Actually, I'm having a issue. Yes, I'm getting one.
You are getting 1. So that means it's not equal to 0. Clear? So in this case, your gx is not a factor because your remainder, this is what? This is remainder, right?
Yes, ma'am.
Okay, so that means your remainder is not 0. Okay. Now quickly finish third and fourth part very quickly. Yeah, third part. How much is p at -1? What is the value? Zeba, what's your answer?
I'm getting ones which is not a factor.
Yes, it's not a factor. Very good. Fourth one. Now quickly find it. Yeah, fourth one. How much is the value of P at -1? So Zeba, what are you getting? Jocelyn, what's your answer?
I'm getting to root 2. That
2
means
root.
not a factor.
Yeah, so that implies that gx is not a factor. Okay. Now, second question. Again, look at the second question. So use the factor theorem to determine whether gx is a factor of px in the following cases. Same problem, right? So if the remainder is 0, then gx is a factor. If it's not 0, gx is not a factor. I hope the concept is now clear. So
Yes,
now,
ma'am.
okay, so the only difference is they have different gx in every part, right? Okay, so there is some polynomial and there is some gx. So the polynomial is 2x cube plus x square minus of 2x and minus of 1. Now in this case, the gx is x plus 1. So you have to find the value of x from here. So you put your gx is equal to 0. So that means x plus 1 is equal to 0. So that implies x is equal to minus of 1. Again, same. So you will find p at -1. Now find it and tell me what's the value.
The first one is a factor because I got 0.
Okay, very good. So it will be 0. It's a factor. Now second one. So gx is x plus 2 in the second one, right? So that means x is equal to minus 2. Jaslyn, if you have completed this part, you can proceed to the next part. So please revise this exercise today. Please keep on doing all the questions. Yeah, Zeba, how much is P? How much is the remainder?
The remainder is -1, so
Hmm.
it's not a factor.
Okay, very good. Okay, so third part that you can complete. Now let's see the third question. Okay. So you are having a book, right?
Yes, ma'am.
Okay, fine. Now third question, Zeba, right? So find the value of k if x minus 1 is a factor. See, in this question, it's already given that it's a factor, okay? You don't have to check. Is it clear?
Yes, ma'am.
So when it is already a factor, that means remainder is 0 now. Is it clear? So it's already given that remainder has to be 0. Okay. So first part, px is this. X square plus x and plus k. This is your px. And your gx is this x minus 1. Is it clear? Now
Yes,
gx is already a factor. That means, okay, from gx, first of all, you find the value of x. Put gx is equal to 0. So that means x minus 1 is equal to 0. That means x is equal to 1. Clear? So what is the remainder? So p at 1 is the remainder. Now this remainder is already 0. Is it clear?
yes, ma'am.
Okay. So p at 1 is already 0. So what is p at 1? So you put 1 everywhere. So that means 1 square plus 1 plus k. Now this is already 0. Clear? So 1 square is 1 plus 1 plus k is equal to 0. So 2 plus k is equal to 0. So that means k is equal to -2. Simple.
Yes, ma'am.
This is the step which you have to do. You have to put it equal to 0 because it's already a factor. Gx is already a factor of px. Okay. So remainder is
Yes.
0. Now do the second part quickly. Same way. Jesslyn, you also please find the value of k in the second part. Jaslyn, any particular question you are having problem here? Yes, Zeba. How much is K second part?
2 plus root 2.
Second part is 2 plus root 2. Yeah, that's fine. See, you have to do it honestly, Zeba, okay? Yourself. Don't look at the notes.
Yes, ma'am.
Yeah, okay. So third part, fourth part, now you can do. You know the method. Now let's see the fourth question of this exercise. Now you have to factorize. So first part, this is 12x square minus of 7x plus 1. So we already discussed there is a method which is called middle term splitting, right? This method you will use in this question. So this is a polynomial. You have to break it into factors. Is it clear?
Yes, ma'am.
Now, what is the see, this is of this form, ax square plus bx plus c. Please try to understand. Okay. So the first step is, as I told you, you multiply a into c. So first we multiply a into c. So that means here we will multiply 12 into 1. So you get 12. Is it clear?
Yes, ma'am.
Okay. Now you do prime factorization of this 12. So 2 into 6, 2 into 3, 3 into 1. Okay. Now, out of these factors, 2, 2, and 3, you have to make combination so that you get this minus of 7 in the middle. So if you just combine this, 2 into 3 is 6. No, no, no. You can do this 2 into 2, 4, and then 3. Is it clear? So minus 4
Yes, ma'am.
and minus 3 is going to give you minus 7, right? So this way we are going to break this 12. So we are basically breaking this a into c. So this 12x square minus 7x plus 1. Now this minus 7x can be broken down like this. So minus of 4x minus of 3x. Is it clear? And plus 1. Now simple. So this is the main step of this method. Now from the first two terms, you can take something common, and the next two terms, you can take something common. So first two terms, I can take 4 common and I can take x common. So here I get 3 only, 3 and 1x, right? Now only minus 1 will remain. Clear?
Yes, ma'am.
Okay. Now from these two terms, see, if you take only one common, so you will get minus of 3x and plus of 1. But here you have minus of 1, right? So you take minus of 1 common. So this minus is already outside now. So this will be plus now. And the second term, which was already plus, this will be now minus. Is it clear? So here, like maximum mistakes are done when you are taking minus outside. So the term which was already minus, so 3x was minus, okay? Now it will be plus and 1 now minus. So all that sign will change of all the terms. Now,
Can you
hmm,
explain me that again? I didn't understand it.
sorry, say again.
Can you please explain me
Hmm,
again?
okay. So, 1 minute. See, Zeba, first of all, I need this bracket 3x minus 1, and I also need 3x minus 1 here also in the next bracket, okay? So if I take only one common outside, because there is nothing common in these two terms, so I can take one common, right? But if I
Yes,
take
ma'am.
plus 1 common, so I get minus of 3x and plus 1, which is different from this bracket, isn't it?
Yes, ma'am.
So I take minus of 1 outside, not the plus 1. So if I
Yes.
take minus of 1 outside, so this minus of 3x will become plus of 3x and plus of 1 will become minus of 1. So that sign of all the terms will now change. Clear? So now this bracket is same. So I can take this bracket common. So here I get 4x and then minus of 1. So now you can see I have broken this polynomial into 2 factors. Is it clear?
Yes, ma'am.
So that's it. Just so when we started with this polynomial and then we reach here. So these are the 2 factors, 3x minus 1 and 4x minus 1. So we have factorized this polynomial.
Yes, ma'am.
Okay, now please try the second part. So second part is this 2x square plus 7x and plus of 3. So what will you do first of all, Zeba?
First, people multiply with 2 and 3.
Hmm.
And this is the prime factor.
6, yeah. So prime factors of 6.
Yes.
What are the factors? Yeah, so 2 into 3 and 3 into 1, right? Okay, so how will you get this plus 7x now? See, Ziba, 2 plus 3 is 5, right? Which is a smaller. So you can do one thing. You can take this 6 and then you can multiply this 1 by 1. Any problem? So 6
No.
and 1, this you can take. So 6 plus 1 is
Yes.
7. Hmm.
Yes, ma'am.
Now please factorize it. So Ziba, in your school, like have they cut any exercise from this chapter?
Uh, just they have removed the remainder theory.
But that is important. Like without knowing the remainder theorem, how will you solve all the questions? See, we are using remainder theorem so far, right?
Yes.
This is from remainder theorem, which says that P at A is a remainder. This is actually from remainder theorem. I don't know why they have cut it. Okay, anyway, let's solve it.
Done, ma'am.
Yeah, what are the factors? Yeah, say again. So in this form, like what are the factors you are getting here? So what is the final answer that you can tell me? I can't hear you, Zeba. Please unmute yourself. Zeba, please unmute yourself. Jesslyn, any problem here? Okay. So anyway, Jesslyn, just do again all the exercises up to 2.4. Please solve them on your own without looking at your notes this time, okay? And then see how much you're able to do. Yeah, Zeba, can you hear me now?
Yes, ma'am. Can you hear me? The answer is x plus 3 and 2x plus 1.
That's good. So Zeba, now today what will you do is you will solve all the questions again without looking at your notes this time. Clear? And very honestly, you will solve up to fourth question